A glacier is a large, perennial accumulation of crystalline ice, snow, rock, sediment, and often liquid water that originates on land and moves downslope under the influence of its own weight and gravity. Typically, glaciers exist and may even form in areas where 1. Mean annual temperatures are close to the freezing point. 2. Winter precipitation produces significant accumulations of snow. 3. Temperatures throughout the rest of the year do not result in the complete loss of the previous winter's snow accumulation. Over multiple decades, this continuing accumulation of snow results in the presence of a large enough mass of snow for the metamorphism from snow to glacier ice process to begin. Glaciers are classified by their size, i.e., ice sheet, ice cap, valley glacier, cirque glacier, location, and thermal regime, i.e., polar versus temperate. Glaciers are sensitive indicators of changing climate. Glaciers are massive bodies of slowly moving ice. Glaciers form on land, and they are made up of fallen snow that gets compressed into ice over many centuries. They move slowly downward from the pull of gravity. Most of the world's glaciers exist in the polar regions, in areas like Greenland, the Canadian Arctic, and Antarctica. Glaciers also can be found closer to the equator in some mountain regions. The Andes mountain range in South America contains some of the world's largest tropical glaciers. About 2% of all the water on Earth is frozen in glaciers. Glaciers can range in age from a couple hundred to thousands of years old. Most glaciers today are remnants of the massive ice sheets that covered Earth during the Ice Age. The Ice Age ended more than 10,000 years ago. During Earth's history, there have been colder periods when glaciers formed and warmer periods when glaciers melted. Scientists who study glaciers are called glaciologists. Glaciologists began studying glaciers during the 19th century in order to look for clues about past ice ages. Today, glaciologists study glaciers for clues about global warming. Old photographs and paintings show that glaciers have melted away from mountain regions over time. Indeed, glaciers worldwide have been shrinking and even disappearing at an accelerated rate for the past several decades. Among the scientists studying the changes in glaciers is Erin Christine Pettit, a glaciologist at the University of Alaska Fairbanks. Pettit observes and measures the flow, fracture, and retreat of glaciers. She uses this information to study how much water enters the oceans from melting glaciers. Melting glaciers are one factor contributing to the global sea level rise. A glacier forms where the accumulation of snow exceeds its ablation over many years, often centuries. It acquires distinguishing features, such as crevasses and seracs, as it slowly flows and deforms under stresses induced by its weight. As it moves, it abrades rock and debris from its substrate to create landforms such as cirques, moraines, or fjords. Although a glacier may flow into a body of water, it forms only on land and is distinct from the much thinner sea ice and lake ice that form on the surface of bodies of water. On Earth, 99% of glacial ice is contained within vast ice sheets, also known as continental glaciers, in the polar regions, but glaciers may be found in mountain ranges on every continent other than the Australian mainland, including Oceania's high-latitude oceanic island countries such as New Zealand. Glacial ice is the largest reservoir of fresh water on Earth, holding with ice sheets about 69% of the world's fresh water. Many glaciers from temperate, alpine, and seasonal polar climates store water as ice during the colder seasons and release it later in the form of meltwater as warmer summer temperatures cause the glacier to melt, creating a water source that is especially important for plants, animals, and human uses when other sources may be scant. However, within high-altitude and Antarctic environments, the seasonal temperature difference is often not sufficient to release meltwater. Since glacial mass is affected by long-term climatic changes, example precipitation, mean temperature, and cloud cover, glacial mass changes are considered among the most sensitive indicators of climate change and are a major source of variations in sea level. A large piece of compressed ice, or a glacier, appears blue, as large quantities of water appear blue, because water molecules absorb other colors more efficiently than blue. The other reason for the blue color of glaciers is the lack of air bubbles. Air bubbles, which give a white color to ice, are squeezed out by pressure increasing the created ice's density. A glacier originates at a location called its glacier head and terminates at its glacier foot, snout, or terminus. Glaciers are broken into zones based on surface snowpack and melt conditions. The ablation zone is the region where there is a net loss in glacier mass. The upper part of a glacier, where accumulation exceeds ablation, is called the accumulation zone. The equilibrium line separates the ablation zone and the accumulation zone. It is the contour where the amount of new snow gained by accumulation is equal to the amount of ice lost through ablation. In general, the accumulation zone accounts for 60 to 70% of the glacier's surface area, more if the glacier calves icebergs. Ice in the accumulation zone is deep enough to exert a downward force that erodes underlying rock. After a glacier melts, it often leaves behind a bowl or amphitheater-shaped depression that ranges in size from large basins like the Great Lakes to smaller mountain depressions known as cirques. The accumulation zone can be subdivided based on its melt conditions. The dry snow zone is a region where no melt occurs, even in the summer, and the snowpack remains dry. The percolation zone is an area with some surface melt, causing meltwater to percolate into the snowpack. This zone is often marked by refrozen ice lenses, glands, and layers. The snowpack also never reaches the melting point. Near the equilibrium line on some glaciers, a superimposed ice zone develops. This zone is where meltwater refreezes as a cold layer in the glacier, forming a continuous mass of ice. The wet snow zone is the region where all of the snow deposited since the end of the previous summer has been raised to 0 degrees Celsius. The health of a glacier is usually assessed by determining the glacier mass balance or observing terminus behavior. Healthy glaciers have large accumulation zones, more than 60% of their area is snow-covered at the end of the melt season, and they have a terminus with a vigorous flow. Following the Little Ice Age's end around 1850, glaciers around the Earth have retreated substantially. A slight cooling led to the advance of many alpine glaciers between 1950 and 1985, but since 1985 glacier retreat and mass loss has become larger and increasingly ubiquitous. Glaciers are one of the most intriguing elements in our natural environment. To the geologist, glaciers are a never-ending source of fascinating information and discovery. Glaciers are sensitive and dynamic. They move and respond in many different and subtle ways to changes in the environment. They have been larger and more numerous in the past and could possibly return to assume a more extensive role in the future. Glaciers inherently present great potential for systems modeling as evidenced in the following. A glacier is bounded in space by the geographical features of its domain. A glacier is a body of ice subject to mass balance. A glacier, by its very nature, exhibits change over time. Accurate systems models are possible for any bounded, conservative system such as a glacier. The MTM approach provides an effective basis for modeling, since systems analysis and modeling proceed hand in hand. The most macro level of analysis yields a model of simplest detail, providing mass balance for only the system domain, a bounded region of space, over an extended period of time. Progressively more micro levels of analysis yield models that articulate increasingly greater detail. Knowledge about the system domain is obtained by inspection of the system from books and articles describing the system and from knowledge acquisition sessions with domain experts. 1. Glaciers are huge masses of ice that flow like very slow rivers. They form over hundreds of years where fallen snow compresses and turns into ice. 2. Glaciers form the largest reservoir of fresh water on the planet. In fact, they store 75% of the world's fresh water. 3. Today, glaciers cover around 10% of the Earth's total land area. During the last ice age, they covered 32%. 4. Glaciers are usually divided into two groups: alpine glaciers, which form on mountainsides and move downward through valleys, and continental ice sheets, which spread out and cover larger areas. Watch two National Geographic explorers team up to cross the world's 20 largest glaciers. 5. The world's largest glacier is Lambert Glacier, located in Antarctica, measuring approximately 100 kilometers wide, 400 kilometers long and 2.5 kilometers deep. 6. Because glacial ice is so dense and compact, it often appears a bright blue color. 7. The Kusha Glacier in Pakistan has the record for the fastest glacier surge. In 1953, it moved more than 12 kilometers in 3 months. 8. Earth's two ice sheets cover most of Greenland and Antarctica and make up more than 99% of the world's glacial ice. Check out ice caves with National Geographic explorer M. Jackson. 9. If climate change caused the Antarctic ice sheet to melt entirely, it is estimated that sea levels would rise by around 65 m. That means that London would be lost underwater. 10. Glacial ice can be hundreds of thousands of years old, which makes it a valuable resource for assessing climate change. By extracting and analyzing the ice, scientists can learn about what the climate was like on Earth thousands of years ago. Thank you for watching this video.